Good morning, good afternoon to Germany. A very warm welcome to this webinar today. In this webinar, we're going to discuss renewable hydrogen in wastewater treatment plants in Brazil, a study that we have conducted on behalf of the Export Initiative Environmental Protection from Green Tech, made in Germany, from the German Ministry for Environment, Nature Conservation, Nuclear Safety, and Customer Protection. My name is Luana Lima. I am the Deputy CEO of the German Chamber of Commerce in Rio de Janeiro and also representative in Brazil for the state of Baden-Württemberg. And with no further and longer words, I would like to hand over to my colleagues Lea von Bressensdorf and Katharina Horn for the greetings.
Thank you so much, Luana, and good morning to Brazil. Good afternoon to the participants from Germany. And I also saw there are some people even from other countries. So hello to all of you as well. And thank you so much for joining this webinar today. My name is Lea von Bressensdorf. I'm project lead at Chambers for Green Tech at DHK, which is the headquarter of the German Chambers of Commerce. And I'm here based in Berlin. And I just want to provide you very, very shortly with some context on this webinar today and also on the study that we are presenting. So as Luana has mentioned, the study and also the project team Chambers for Green Tech is financed by the Ministry for the Environment within the Export Initiative Environmental Protection. This is a funding program that aims at promoting green innovation on an international level. I will also post the link to the funding program in the chat so you can find some more information in case you are interested. The Export Initiative in general is open to German companies and universities and research institutes, but we as Chambers for Green Tech coordinate a special part of the program, which is projects implemented by the German Chambers of Commerce abroad, the AHKs. Those projects focus on three areas mainly, which is water technology, circular economy, and as in this case, green hydrogen for decentralized and local users. These are implemented in all different parts of the world. And in the case of green hydrogen, which is the topic today, we have implemented so far projects in 6 different countries. Ranging from the Philippines on one end of the world to Nigeria, and also in South America, where we have this project here in Brazil. And also we had a project in Chile on green hydrogen. And with Brazil, we have also worked in the past with Luana and her team on water technologies also. So this is a very strong focus of our program as well, and we're always happy to collaborate. The focus is on capacity building and transfer of know-how and technology. So this is a bit the context, and I just want to mention also that this project in Brazil and in Rio is a very special one to us. First, of course, because of the dedication, all the hard work that Luana and her team and Ana Beatriz put in, but also because we have such strong local partners who are very, very involved in the project with Sanepar and CE Biogas, which is really core to the project and made it very interesting to us as well. One of our tasks as Chambers for Green Tech is also connecting the HKs with German companies and German strategic partners. And one of them is the NOW, which is the National Organization for Hydrogen and Fuel Cell Technologies. And they are in all our hydrogen projects. They are an important part is our technical partners that bring in the expertise and the connection to German companies in the sector. And in this case, Katharina Horn was very involved in the project as well for NOW, and I would like to hand on to her so she can give a bit on an insight on what the Export Initiative Environmental Protection does in green hydrogen. So thank you very much, and I hope we all have a very, very interesting webinar.
Yeah, thank you, Lea, and also from my side, a very warm welcome to everyone. It's great to see so many of you from Brazil and Germany and other parts of the world interested in the topic that the AHK in Rio analyzed within their project together with the local partners that are also present. So also very warm welcome to you. Good to see you again here. And yeah, I would just like to briefly introduce, as Lea mentioned, why we also take a stake in this project. We as NOW, we are the National German Organization for Hydrogen and Fuel Cell Technologies here in Germany. And we are a 100% publicly funded company that coordinates, implements, evaluates, and shapes funding schemes on behalf of different German federal ministries in the field of hydrogen and fuel cell technologies. And these funding schemes all have the global goal of fostering implementation of technologies along the whole hydrogen value chain. We also coordinate different networks in the interface between research and development, industry and politics on a local German, regional, and also an international level. And within the EXI, we, as well as our cooperation partners with the Chambers for Green Tech, we act on behalf of the Federal Ministry for the Environment. And our role as NLW here is to support the implementation of the EXI projects within the action field of green hydrogen and fuel cell technologies. And our role basically is to support the implementation of projects and also their stakeholders, of course. We are like a consulting partner for the different kinds of projects within EXI, such as the AHK projects, but also for pilot and demonstration projects where technologies are implemented on the ground. We also can commission, for example, specific studies on different matters, such as techno-economic aspects within the field of decentralized power supply with hydrogen and fuel cell technologies, and try then to bundle the knowledge that is created in AHK projects, for example, the pilot projects, and further knowledge to then make it also accessible to other relevant stakeholders in the public and private sector. And we also try, of course, to support the projects wherever connection with industry or research stakeholders is needed. And I think, yeah, the project we're talking about today and learning more about is a very good example where we could connect a few dots and make the connection between German stakeholders, such as the consultant Blue Move Consulting with Arthur Dornburg present today, and AHK, and of course local partners, Sanepar and CE Biogas. So without any further ado, I would like to hand back to Loana and yeah, also give the word for the other project partners to present themselves.
Thank you very much, Lea and Katarina. And yes, it was a huge pleasure and a joy working with you, having you as a project partners and conducting the study, but also a huge pleasure working with our local partners, CE Biogas and Sanepar, and our international partner, Blue Move Consulting, right, directly from Germany. So we're moving now to a very brief introduction round for you to also to know which companies, which institutions, apart from NOW and German Chambers for Green Tech, were involved in this project and which was the role of each partner. So starting, since I have already my microphone open, starting with the AHK, the German Chamber of Commerce in Rio de Janeiro, Brazil. We have proposed the project, of course, and of course, from the very beginning, aligned and identified our potential partners in Brazil, our partner in Germany, our consulting partner in Germany, and we did mainly the project management of this study. So our main goal as a chamber was to do this network and also this interface between the local demands, the local necessities, and the local deliverables, so to say, of the study, and also matching with the demands and requirements also from the German side, from this program, so to say. So it was a huge pleasure, and I'm a kind of, I must say, sad that this project has come to an end, but also very happy that this study was very successful, and looking forward also for our colleagues and our partners to present the study now to you, and for a huge discussion and very, yes, constructive discussion afterwards. So moving on, I would like to hand over to Natalicio Reason. He is Director of Innovation and New Business at Sanepar.
Good morning and good afternoon to the German. Thank you for the presentation. It's for me it's a pleasure it's possible to talk small words for all the people. On behalf of Sanepar, I'm honored to greet all attendees of this webinar. We would like to express our profound gratitude for the partnership in development of the significant pre-feasibility study. In particular, we extend our thanks to the government of the Federal Republic of Germany by means of the Federal Minister of the Environment, Natural Conservation, Nuclear Safety, and Consumer Protection for believing in your proposal and to now for their dedicated support during this journey. We also wish to cover our sincere appreciation to the German-Brazilian Chamber of Commerce and Industry for their consistent participation from the project submission to this final products. Additionally, we thank the consultants CBioGas and Blue Move for the fruitful discussion an excellent technical contribution that significantly enhanced the success of this project. At Sanepar, one of the leading water and sanitation utilities in Latin America, and a world reference in achieving sustainable development goal 6, we firmly believe in a strategic alliance for the consolidation of new sustainable low carbon production arrangement and the energy transition. This project, which explored the potential of renewable hydrogen production for sewage treatment and ordinary activity of your company, clearly exemplifies this vision. The results obtained allow us to envision innovation pathway for consolidated opportunity that will strengthen our core business, promote public health and quality of people life, and enhancing value created for society. We are immensely grateful for this honorable partnership and wish everyone an excellent event. Thank you very much. I'm sorry for my English.
Thank you so much, Natalicio. Now I'd like to hand over to our colleagues from CEBioGas. Felipe Marques, he's Director of Technology Development at CEBioGas.
Hello, Luana. Nice to talk to you again. It's a mix of feelings, as you said, about the ending of this project, because there is a lot of lessons learned. So the better understanding of the near future that we can have as we address the right way the efforts. Give me some positive vibrations to the next months, next years, especially here in Paraná. And I really like to thank you for the cooperation, because there's no way that we could deliver such an important project in this time shuttle without a truly and respectful cooperation. So I guess we are connected. We are a science, technology, and innovation center dedicated to the biogas and biomethane sector. So everything we can do with biogas and biomethane, it's we give the right attention to it. So the hydrogen possibilities are a good way to make more value with biogas. So we are on it. So we are very proud about our cooperation. Thank you.
Thank you very much, Felipe. And last but not least, Arthur Dornberg, CEO from Bull Move Consulting. Hello, Arthur. You're muted.
Okay, good morning to Brazil and hello together. It was a very big pleasure for me to work together in a partnership with Brazil and Germany. And it was a big pleasure to share the experience about the projects. Our main business is on a strong focus of energy efficiency and also decentralized energy production. The technologies we follow is PV panels, but the most of them is cogeneration. Cogeneration for us, it means natural gas, but also biogas, and now since few years, hydrogen. The customers are in the building sector and industry, nearly all kind of industry, and wastewater treatment plants. Our field of engineering is to realize the project and also the contracting, it means the business models. And we have a very strong high-level target in the projects now. It's not only energy efficiency, it means positive electricity balance. And that is very important for us for the hydrogen project because it's a very big requirement for this kind of hydrogen. And the second requirement for us for decentralized project is because the projects are very expensive. So we work without of transport from hydrogen from A to B. So we use the hydrogen close to the production place. Thank you.
Thank you very much, Arthur. So, dear attendees, now you know who participated mainly in this project. And with no further long delays, I would like also now to move to the presentation of the main results of the study, because it's not only about the farewell and saying how nice was working with our partners during this project, but also giving you and providing you the content and the main results of the project. This presentation will be done by Gabriela Bonassa. She's from the technical team from CI Biogas, and also from Fernanda Janaína Costa from Sanepar. She's an engineer at Research and Innovation Department at Sanepar. And while they are presenting the results of the project, the main results, well, I will also put the link for you to get the detailed documents of the project in the chat. And I would like also to emphasize that our goal after this project is also to spread information, to spread the content. So in case you want to know better the project, or you're hosting an event, a webinar, or congress, and would like us, being me, HK as AHK, or CI Biogas, or Arthur in Germany, or Sanepar, we are very open also to bring the content, to discuss it together with you, because the one of the main goals of the project is also to multiply the information, the results for other applications in Brazil. So, Gabi, please, the floor is yours.
Thank you, Luana. Good morning. Thank you for everyone that are with us in this morning. We are going to show some results from our project that is about adding value to renewable hydrogen from wastewater treatment plants. I will ask to Janaína to start with some concepts about Sanepar.
Hello, everyone. It's a pleasure to be here today to share insights and discuss this project. So in the Paraná state, we have around 200 wastewater treatment plants in operation, and we produce biogas from anaerobic reactors, and less than 1% is biogas from electricity heat or biomethane. And in this project, we estimated the biogas potential around to 20 million meters per year, and these estimates provide an optimum environmental for introduction of technologies for exploited of the use of biogas of rich methane and this production of renewable hydrogen based of different technologies and routes.
Thank you, Janaína. So, as was told, we have a lot of wastewater treatment plants here in Paraná, and less than 1% are using the biogas to electricity, heat, or biomethane. And this creates a good environment to hydrogen production. And as Felipe told about Say Biogas, we are players in the biogas and biomethane chain. And when we look to biogas and the opportunities to hydrogen production, this is a good point because we have a lot of routes that we can make research and develop to the market. In this case, it's not about only electrolysis or catalytic routes, but also about other routes and a match about these routes to produce hydrogen. So one of them is the electrolysis, is the route most developed in the concept of renewable hydrogen, and how we can apply this to biogas. We can use biogas in a generator, then we have renewable electricity, and this electricity we can use in electrolyzers to produce hydrogen. We have a lot of types of electrolyzers in our market, including the alkaline, the PEN, and the high temperature ones. The advantage of this route is the high technological readiness level, since are technologies that are available on the market. Other route that is also the with high development, since is the route most used to produce fossil hydrogen, is the catalytic reforming. So based on the process that is usually applied for producing hydrogen from natural gas, we can use this route to biogas or to biomethane. We have dry reforming, steam reforming, or autothermal reforming. When we have biogas with composition of methane and CO2, we can use the dry reforming. When we have only biomethane, we use the steam reforming. And when we have biomethane, water, oxygen, we can use the autothermal reforming. The steam reforming is the most developed, and Sanepar with Say Biogas are also developing some research with the dry reforming. Other routes that we can apply, looking for other products from this chain, we have the plasmolysis. The plasmolysis is a route that we can apply for biomethane or for wastewater treatment, that both we have in wastewater treatment plants. In the case of the plasmolysis of biomethane, we produce hydrogen and elemental carbon or carbon black. In the case that we use the effluent in the plasmolysis, we also produce hydrogen, carbon, and nitrogen that can be used in the fertilizer industry. And other source from wastewater treatment plants that we can use to produce hydrogen is the sludge. And in this case, we apply the route based on hydrolysis and gasification. So with 2 steps, we produce syngas from the sludge from wastewater treatment plants. So one point that we have to stand out about the biogas and hydrogen and how we connect these ideas is about this, that we can use a lot of roads and we have a lot of other products that also have value to this chain. On this project that we developed, we chose the steam reforming as a route to evaluate how much hydrogen we can produce and the environment impact of this route. And why to choose the steam reforming? So we have a lower carbon footprint when we compare it to natural gas. We have lower energy and water demand when we compare to electrolyzers. We have a high technological readiness level, and we have some suppliers in the Brazilian and also in the European chain, like Hytron from Neumann and Esser, Host, BTX, Metacon, and Helbill. So for the all more than 200 wastewater treatment plants, we evaluated the potential of hydrogen production based on this route. And some of the results that we obtain is since these wastewater treatment plants can produce more than 23 million cubic meter per year of biogas. And when we use all of this biogas to produce hydrogen, we can produce around 7 tons per year of hydrogen. And this hydrogen can be produced in all of the Paraná state, since we have a lot of wastewater treatment plants. And talking about Curitiba, it's the region that can most produce hydrogen, and the number is around 2 tons of hydrogen per year. Looking for the suppliers and the demand of hydrogen in Paraná state, we have around 300 consumers of hydrogen in Paraná. It's important to highlight that all of these consumers use fossil hydrogen. But when we think about the climate goals that we have in the next years, and think about that we can produce hydrogen, we can change in the next year these numbers with also who will use renewable hydrogen. And another point is that from these 300 companies, most of them are also in the Curitiba region. And the environmental impact of this process. So, if all the biogas produced by Sanepar is released into the atmosphere with no use, we have around 300,000 equivalent tons of CO2 per year being released. This is not the scenario adopted by the company, and it's just an example. But if we use all of these biogas to produce hydrogen based on the steam reforming, we have the mitigation of around 300,005 equivalent tons of CO2 per year. And what this means? That the production of hydrogen from biogas is in line with the climate goals that we have, the decarbonization, energy transition, that are until the next years that we need to reduce CO2 emissions. I think that Luana sent to you in the chat the links of our study, but here we also have the codes of a infographic, a digital infographic with the wastewater treatment plants and the potential production, and also our feasibility study. Thank you.
Thank you very much. Janaína, would you like to give some words, or are we done with the presentation?
Just this.
Okay, thank you very much. Now, so now we move to the discussion panel, which I think is also very interesting for you, dear participants. Let's talk a little bit more about the main takeaways and let's share some experiences with the subject that we have, which is, of course, the generation of renewable hydrogen in wastewater treatment plants, but also the applicability, right? So let's talk about business models. So we have now in this panel, will participate Gustavo Possetti. He's the head of research and innovation at Sanepar. In CI Biogas, we have Felipe Marques, Director Technology Development, and from Blue Move, Arthur Dornberg. So I think my colleagues are trying to have everyone in the screen, so that's perfect. Thank you very much. Starting with Arthur from Blue Move Consulting, I would like to ask you, Arthur, what were not your point of view? Because Arthur had the opportunity not only to contribute to some working packages in the study, but also to be here in Brazil twice to visit the Sanepar's wastewater treatment plants and to see with his own eyes, so to say, the potential, the challenges of hydrogen generation. So my question, Arthur, is what were the main differences between the H2 and the derivatives, which is the PTX technologies in the Brazilian and German markets that you noticed during the development of the project, during your visits here? Can you tell us a little bit about this?
Yes, hello, thank you, Luana. At first, I think we had a very good basement because both countries had a lot of experience and projects in field of renewable energy. I think both countries are very strong in these markets. And now to the difference. I think in the field of renewable energies, Brazil has nearly 100% of renewable energies. For us, it's like a dream because we have nearly 40–50%. It's a very big difference for us, and Brazil is much further in this part. The second difference is in relation to hydrogen. I think for Brazil, they have a strong focus to export the hydrogen. In our country, we need the hydrogen for ourselves, so we have a focus for small projects and then to import the hydrogen. I think that's the second big difference from the countries. And for that, we have different in the projects. Our projects are decentralized projects and have a strong focus to the traffic sector. Sometimes for me, it seems like each village needs its own hydrogen petrol station, but that's stupid, as according my opinion. But so we have a lot of projects in this field. But also we have very good and strong projects and bigger ones in the industry, especially in the steel industry. And we have some project, and one of them we realized now in the south of Germany in wastewater treatment plants, because we worked since a long time in wastewater treatment plants, and if we have there a positive energy balance, so we have to decide what's going on if we produce electrical power or green gas or now hydrogen. And for hydrogen, we have a lot of opportunities and technologies, but we are still in the beginning. And for me, I think Brazil have much more opportunities around of wastewater treatment plants, because the traffic sector, I think in Brazil is not so important because they have a lot of other green opportunities and a lot of experience there. And in wastewater treatment plant, Brazil have more opportunities and bigger player like Sanepar than in Germany. So I think it's much easier to realize this kind of projects in Brazil and also to test the technologies with pilot projects. So I think it's a good idea to continue the ideas from the last years to realize 1 or 2 projects in Paraná.
Great, Arthur. Thank you so much for this initial comments on your perspective about the difference between the H2 and PTX markets in Germany. So yes, Brazil has a huge potential for exporting hydrogen derivatives, but also applying it to the local market. So especially when we talk about the biogas, the biomethane generation from to hydrogen. You also mentioned about smaller projects in Germany and application to the industry, whereas in Brazil, maybe there's a huge potential also for the wastewater treatment plants. Since you're right, the application of PTX technologies in our transportation sector. Well, we have other opportunities and well-consolidated technologies and in the field of biofuels, for example. So talking about biogas and biomethane, I would like also to reach a question to Felipe from CI Biogas, which is, Felipe, can you comment a little bit on which opportunities have opened up from this project, from this study to the biogas and the biomethane sector as energy feedstocks for the H2 generation?
Yes, Luana, thank you. If you see the biogas recent history in biogas, you will see that we moved from 93 biogas plants to 1,385 biogas plants in the last 10 years. So the biogas, it's really an important energetic asset that we have here in Brazil. And as it growed, we started using for thermal applications, electricity, biomethane. It's the main it's the main drive now. But there is these other possibilities as we can produce the hydrogen. So there is the biogas. It's a really it's an energetic that has a strong connection with the territory. So what happens in the territory defines from which substrate we will produce the biogas and for what we are producing the biogas. So with this project, we have a really strong understanding on how biogas can fit the industry demands on hydrogen production using biogas. So this is the main opportunity that we have, because there is some substrates, there's some industries that today look for the biogas typical applications and they don't see a business for them. But now, considering the hydrogen production, the hydrogen delivering hydrogen for the industry, they understand that, okay, now I have a business model that fits. The connections that I have will be strongly use it to make more business with it. So with this project, now we understand really better how we can offer the biogas to produce the hydrogen. So we can offer the hydrogen, and we can we have better understanding of about the demand on how much I want, how much I'm willing to pay for it, in which way I need to receive it. And as we have the offer and the demand, we have better understanding on the path, and this is really strong on the value chain. So now we have a strongest message to the technology providers on how which is the effort that we have to do to start delivering hydrogen through biogas in Paraná state, and there is there is a lot of good opportunities that we identify. It's better than we thought in the beginning. I have to say that we have we were positive on the results, but it's better than we could imagine, especially on the number of potential buyers of the hydrogen. So this better understanding makes it possible to deliver hydrogen with biogas in Paraná, and the noise, I can say, it's being made. So there's a lot of expectations on the Paraná state industry. So we will have to deliver soon enough. Okay.
Thank you very much, Felipe. Well, very exciting about your comments and the opportunities that have opened up for the biogas and biomethane market. As we heard many times during the project by Mr. Dornberg, it's also, of course, very important not only to see the substrate and the application, for example, from biogas to hydrogen generation, but also the application side. So I think this is one of the main added values to the main deliverables from this project to really match the potentials from hydrogen generation and the application to each sectors, to each industry. So again, congratulations for the hard work from the entire team and for the coordination as well. Before I hand over to Gustavo from Sanepar, I also like to motivate you. I have seen there's already one hand raised, and we'll open up for questions and comments afterwards. So feel free to write your questions in the chat, in the P&R function as well, or just raise your hand, and after this first comments round, with discussion round, we'll open up for questions, okay? So, dear Gustavo, tell us a little bit more about what were the main developments, not only from the biogas, but for the main takeaways as well for one of the biggest water and wastewater companies in Latin America, and if I'm not mistaken, worldwide. So what were the main takeovers for you? And also, I think what our attendees want to know is, okay, so what are the next steps?
Okay, good afternoon, good morning, everyone. It's my pleasure to stay here with you, Luana. Thank you so much for anyone that can participate here with us. Thank you so much for the opportunity. Some years ago, when we started this discussion, the discussion in line was associated with, it is possible to implement the hydrogen economy in order to contribute with the transition energy movement in the world. Of course, in order to answer this specific question, we try to detect different types of topics in order to develop a pre-feasibility study. And during this specific webinar, we have a lot of answers for this specific topic. But what's next? What can you do in order to continue, in order to follow with this specific movement here in Brazil, in Latin America, specifically at Sanepar? Okay, when we start this specific topic, Luana, we identify that we need reduced risks. So it's extremely important to understand. Sanepar is a utility that works with water and sewage. But what's the connection with the hydrogen? What's the connection with the new value? The connection is the society. It generates value for the society. And for that, we need organize the ideas and establish a roadmap in order to, in the end of the day, improve the quality of the service, improve the quality of the life, and induce a reduction in the tariff. But for that, we need, in the first time, observe all the results and apply in our context. So today, we have a very interesting model because we have a potential and we have off-takers in this specific process. We need to connect this type of things, but we need to start with the technology. We have here different types of technology to produce hydrogen in the sewage plants. But what's the best? In order to identify this type of things, we need to implement projects. And we have, for example, two important projects here in order to observe this specific aspect. The first one, using the Brazilian government cooperation with FINEP and with other important actors here. Copel is a utility that works with energy here, specifically with electricity, and with other partners in the academy, CI Biogas and UFPR. We are understand better the possibility to apply the dry reforming technology in order to produce the hydrogen from the biogas, specifically from the methane and the CO2. And in the end of the day, we have a very interesting final disposal of both gases that we can produce ordinarily in our process and generate hydrogen, in this case, in order to produce electricity and after to use this electricity for cars. So it's a electromobility project, very interesting, that we are implementing here. In 2 years maximum, we have a plant operating here and generating results in order to understand better this specific role, this specific perspective for the hydrogen use. An important lesson learned that we observed during this journey with the German people, specifically during this project, we know different types of companies and startups. And we identify in Germany, for example, a very interesting startup, a disruptive one, which name is Graphorce. And this company implement the plasmolysis, the methane electrolysis, all the same process. We can produce hydrogen, but not only hydrogen. We can produce hydrogen, carbon black, and heat. And this is extremely important in our process, because our idea is not only sell hydrogen, but reduce costs associated with our profits, our process, and if possible, generate new profits associated with that in order to generate value for the society. So I can use the carbon black, for example, as a fertilizer. I can use the heat in order to dry the sludge that we can produce ordinarily in our process. So we believe in these specific types of things that we can connect actors, and that's why we have an NDA and MOU with Graphorce. We visit the first plant operating in scale in Austria some months ago. There is applied the plasmolysis, but use the natural gas. And we hope during the next days implement this type of things with the German people. We are discussing with different types of banks and agencies in order to develop these projects, in order to establish the conditions to implement the first plant using this technology in our context, but in this case using biomethane as a source to produce hydrogen, carbon black, and heat. So we have different types of perspectives here, Luana, associated with that. The next step is implement the pilot and the demonstration scale projects to check this possibility, the mass balance, the energy balance, and of course, we need to combine this type of things with a very financial approach, but observe the environmental and the social approach that we need when we apply the sustainability in our daily activities. So thank you so much, and believe in this approach because it's extremely important for anyone, and we hope that the German people can participate with us during all this journey. Thank you so much, and go ahead, Luana.
Thank you very much, Gustavo, for your always motivating words. So yes, looking forward for the next steps. You talked about technology, you talked about the application now of the studied technologies in the framework of pilot projects, a proof of concepts and everything. So, but without forgetting the environmental and social aspect. So of course, this is very, very important and shouldn't be by any means jeopardized, right? So I would like now to move very quickly to our comments and questions round. So Also, dear attendees, maybe you do not have any questions, but you would like to comment. Maybe you have already some experiences with hydrogen generation in wastewater plants or with the biogas, and you would like to share your experience in your comments. Also, feel free. Okay. I would like to start with Giuseppe Maddalena Stefan. I cannot read the entire name, but he has raised his hand. Let's see if I can unmute him. Okay. Hello, Giuseppe. Can you hear us?
Yes, I can. My question is, if you can take the water from the sea to produce hydrogen by hydrolysis.
Okay.
I wrote the question in the chat.
Yes. Okay. So I have already written your question. So it's a very technical question. I don't know if it's related to our project, but if our colleagues want to, feel free to reply to answer. So could we extract hydrogen from seawater hydrolysis? The technology route will be the hydrolysis. Gustavo, would you like to comment on this?
Mr. Arthur is open for
Yes.
that. We checked during our project some possibilities specifically from the sewage. Go ahead, Mr. Domberg. Specifically, you have a contact in a company in Germany associated with that. Go ahead.
Yes, but anyway, you have to prepare the water for the electrolyzer. So, and if you take the seawater, then you have to much more things to do to prepare and to clean the water. And I think maybe it's a little bit too expensive if you use this kind of water. That's my opinion.
Okay, so it's possible, but maybe unfeasible due to the cost, the operational costs,
Yes.
right? Okay. Gustavo, any further comments on this?
No, only to complete. We have different types of perspectives associated with that. We have a roadmap associated with new technologies, and hydrolysis is one important topic associated with that. In the world, we have some perspectives associated with the sludge. We can transform the sludge using different types of technologies for that, and we can use different types of approach. When we use this specific topic, we need to observe different types of criteria to check what is the best. The TRL, for example, is one criteria. What type of other byproducts we have to valorize the process, the energy cost, and something like that. So only to explain the extremes associated with that. The first one, the electrolysis, is a lot of knowledge about that. It's consolidated technology, but we have a high cost associated with electricity, for example. In other words, we have, for example, the plasmolysis, the electrolysis of the methane electrolysis. In this case, the TRL is increasing, but of course, we are adopting the technology for that because we have a very interesting cost benefits associated with that in a low consumption of electricity. So that's it. We have different types of options. All the day we have a new startup with a new approach associated with that, and we need to observe the technology in order to check the possibility to scale up and to implement the hydrogen economy. That's the topic.
Thank you very much, Gustavo and Arthur. Now, Ulf Behrens, he's from H2 Core Systems, has raised his hand. Hello, Ulf.
Hi, Luana. Thank you very much. Yes, I raised my hand and I'm just writing something in the chat. Actually, I'm from H2 Core Systems and I'm from Flex Biotechnology GmbH, which is a wastewater treatment biogas production company in Germany. And it is in the moment it is not possible to use salted water from seawater. It will harm the electrolyzers for the hydrogen production. It should be desalinated water to be used for the electrolyzers. And one of the important factor in the production of hydrogen through all of the technologies will be the conductivity of the water, and that should be below, ideally below 5 microsiemens per centimeter. So salt water wouldn't fit in, definitely not. There are some advances I think in Australia, where they are doing some research and development on salt water, but they are still far away from it. Thank you.
Thank you for your participation as well.
You're more than welcome.
So, I would also like to highlight, dear participants, that in the materials, mainly in the infographic, you can find also our contacts here, from Gustavo, from Sanepar, from Arthur, from Felipe, from the CI Biogas team. So feel free to move on further discussions with them or with AHK. AHK is, of course, here for assisting also the business relations between German and Brazilian companies. From the German side, mainly small and medium-sized companies. So we are here also for supporting the German environmental technologies, the market entry, and the identification of business opportunities in Brazil. And with that being said, and also taking a look in my watch, I would like to move or to give the word back to Katharina and from Leah, our colleagues in Germany, for the closing. And thank you so much for attending. We had over 100 attendees. I think that's a record and shows the interest and the importance of this subject. And Leah and Gabri and Katharina, please.
Thank you so much, Luana. I don't have a lot to add, and also looking at the time, I just want to say thank you very much to all of you. For me, it was very interesting, and also I think it was really, we could really all see that all of you are very positive about the outcomes of the study, very convinced that the next steps can be very successful, and it was just really, I think, a good moment to also, as you said, Luana, get in touch with the different actors of the projects. We have here some questions that we're not able to answer due to the time. So please really use this opportunity to get in touch with the AHK, which is also part of a global network of AHK. So, and there's also, if you're interested in other applications, other markets, we are also happy to connect you. And yeah, just thank you very much. And Katharina, I don't know if you would like to add something.
Yes, also a big thank you from my side and NOW side, of course. And I think, yeah, the project is really a wonderful example of collaboration for expertise and perspectives from both Brazilian side and also from German side. And yeah, the results really work in both directions. So the German and Brazilian stakeholders are learning a lot from your work. And yeah, we also heard that there's further steps in planning. So yeah, it's a great example of outcomes that can lead to further steps or even technology implementation. And I would really like to encourage everyone just to keep up the topics and keep up the conversations and reach out to the excellent project partners that are involved and presented the results today. So thank you, everyone, from my side.
Thank you so much and have a good day. Bye-bye.
Thank you. Bye.
Bye. Thank you.